In this lesson, we're going to be using some open source extensions that are already available in GitHub. If you go to github.com/smarttracktechnology, all one word, you will find a number of public repositories out there. These repositories will be used in this lesson in some way, shape, or form. You might want to take a moment now before you continue this lesson and download these repositories or clone them to your desktop. Okay, here we are in our development environment, and we want to take a look now at a storage service extension. In the interest of time, I've already loaded up a workspace that has a number of open source service extensions available on our GitHub repository. In particular, for this lesson, we want to focus in here on the AWS storage. Now, in our key interfaces section, we discussed the fact that the storage service interface extends iService as well as health checkable. The primary methods are store, retrieve, and delete. And of course, the delete is an optional method. The storage service extension that you write does not necessarily have to implement the delete method, in which case it should throw an unsupported operation extension. We also talked about the use and the role of the abstract service class. If you're building from scratch, this is where you're probably going to extend. You're going to use the abstract service to extend from to create your concrete implementation. However, there are a couple of other abstract classes available that might be of interest and are worth pointing out. We also define an abstract cloud service. And the interesting thing about the abstract cloud service is it has this generics concept of the credentials and a service key. The neat thing about this cloud service offering is it allows the actual credentials in the service key to be stored in a properties file outside of the source code itself. So in the case of something like AWS, where the credentials are actually an access key and a secret key, this abstract cloud service class helps manage that environment for us. In fact, if you're doing anything with Amazon, all of the various Amazon services extend the abstract AWS service. And this abstract AWS service automatically knows about the names of the keys, access key and secret key, that it should expect to see in a properties file. Now let's look at an actual storage service extension implementation. I'm going to go back over here and I'm going to open up the AWS S3 storage service. And there's a key feature on this class that we need to point out, and that is this annotation of a service extension. By decorating the class with a service extension annotation and specifying that the service type is storage, this enables the jar file that contains this service extension to be able to declare to the Smart Cosmos market how an automated test harness should be applied to it. In other words, this extension annotation tells the test harness I'm a service extension specifically of type storage and you should test me as such. These extension annotations are critical for the Smart Cosmos market. A failure to include the annotation could result in the extension failing to upload successfully into the market. Let's turn our focus to the actual store method, one of the two main required methods on the storage service. The store method accepts a storage request, and storage request objects, as covered in Smart Cosmos lessons, include a couple of key fields. Storage request instances are actually constructed using a storage request builder. And here we can see that that storage request actually includes the input stream that represents the file that needs to be persisted in the remote storage service extension. As part of this input, we also specify the MIME type or the content type of the particular file that's being persisted, as well as how many bytes can be expected in the file. The storage request is handed into the store method, at which point in time a bunch of metadata in this implementation is actually extracted out from the request. We usually use this metadata to provide additional insight about the file in the object's system so that the full file itself doesn't have to be retrieved every time somebody just wants to ask a question about the particular file. Because this is an Amazon implementation, the file is ultimately stored over in Amazon S3 with this put command. And this is part of the Amazon SDK, so the exact syntax is not important here to us right now. But after the file has been stored, what happened next is critical. We have to calculate a checksum, and we can do that using this getSignature request along with the hashutil.sign file. So what we're end up doing here is we say, here is the URL of the file name, and we want to calculate with the sign file method of the hashutil an actual checksum or digital signature of this file and its upload metadata, and we want to put that into a JSON object. And ultimately, the store method must return back a storage response. And we can see the three constituents of a storage response being passed into the constructor. The file itself, the I file, the final URL where the file is resting now over at Amazon S3, and then finally a JSON object representing the checksum and digital signature attributes of the file that was just persisted and stored in the remote location. Finally, let's look at the retrieve and the delete methods for a storage service extension. In both cases, an I file is passed in as the sole argument into the method call. The I file is important because it actually provides the name of the file that we're looking to retrieve or delete, in this case at the Amazon S3 service location. We construct a getObjectRequest, which is an Amazon S3 class, and we actually return back the input stream of the retrieved object from Amazon S3 for the retrieval. In the case of the delete, it's a void return, so no other actions are required.